We know that square root of 25, its principal or positive square root is 5. I want you to consider something though. Since 25 is 5 squared and we're getting an answer of 5, it's as if taking that square root has cut in half the exponent of 2 into 1. We don't really need to write 5 to the first power. When we first learn about exponents, we think of n being a natural number, a counting number, 1, 2, 3, 4, etc., telling us how many copies of A to multiply together. But what if we allowed fractional exponents? We've already extended what we know about exponents to allow for exponent of 0 or negative exponents. One of the rules that came up along the way was if we have 2 exponents right next to each other, there's not another A showing up there in between. They're just right next to each other, and we multiply those exponents. So what if we allow an exponent such as 1/2? And we square that. We get A to the first, or just A. And similarly speaking, switch the order, we're still going to get A. Now, this one relies on that being a real number. The fact that this is happening suggests that we could do the following. We could set these two equal. Provided that the square root gives us a real number by having A greater than or equal to 0. More generally than that, that the nth root of A equals A to the 1 over n. And again, if n is odd, no problems. But if n is even, then A had better be greater than or equal to 0 for these to be two different ways of writing the same real number. And then more generally than that, again referring to the fact that when 2 exponents are right next to each other, we would multiply. Then we could write the nth roots of A all to the nth power. When we rewrite nth root of A as A to the 1 over n, multiply that 1 over n exponent by m and get a single fraction. Then we'd have A to the m over n, and that would also be equivalent to this, provided the first way of writing it had nth root of A is real. So what I like to tell people when speaking face-to-face is roots go underground and we're seeing underground in the denominator of the fraction the index of n. So that can help you with converting back and forth between the two forms, the exponential and the radical form. Roots go underground, so what you see in the denominator is telling you the index of the root.